Alright, Unit 4 Study Guide, problem number 3. We want to find a and b such that this function is continuous and differentiable. So in order to do this, we need to get two equations because we have two unknowns. So let's look at the first part of this, making this function continuous. So in order to do that, we need both halves of these functions to equal each other at the x value of 1. So in order to do that, I'm going to set them equal to each other. Ax minus 2 equals bx squared minus x. And I want them to be equal to each other at the x value of 1. So I can substitute 1 in to this equation for x to get a minus 2 equals b times 1 squared, which is 1, which is just b, minus 1. And last thing I want to do is I want to go ahead and solve this for one of my variables. I'm going to choose to solve it for a. You'll see why in a moment. And I get a equals b plus 1. Now I want to get my second equation. And to do that, I need to look at making this function differentiable, which means that I need the derivative of these functions to equal each other at x equals 1. So I'm going to start by writing the derivative of each and setting them equal to each other. So the derivative of the first one, ax minus 2, is going to be, it's just a, and that's going to be equal to the derivative of the second half of my function, which is going to be 2bx minus 1, because the derivative of x is 1. But again, I'm looking at the x value of 1, so I can simplify this to a equals 2b minus 1. So now I have a equals b plus 1 and a equals 2b minus 1. So I can set them equal to each other, substitute one in for the other, and get b plus 1 equals 2b minus 1. And I can simplify this further and solve for b to get b equals 2. And now I need to substitute this back in to one of my equations. If b equals 2, then a equals 2 plus 1 is 3. And now I can substitute these values back into my piecewise function to complete it. And I get the function f of x equals 3x minus 2 when x is less than 1, and 2x squared minus x when x is greater than or equal to 1. And you can go ahead and check those values and make sure that that function is in fact continuous at 1, which you can do. You can graph it and check it. Then you could graph the derivatives and make sure that they are also equal at 1, or you can just substitute values in. Whichever way you check, you'll find that this is correct.